Okay, this is exercise 13D, applications of integration. Just looking at a few questions here, a few area questions and some harder integrations. So sketch a graph of y equals e to the x and y equals x plus 1 and shade the area between these curves and the lines x equals 0 and x equals 1, and then find the area, that shaded area. So let's just do a sketch. Now, we're going to have to be a little bit precise here. So I'm going to do a little table of values. When x, and we've got sketching the curve x plus 1, and we're also sketching e to the x. I'm going to do a little table here. Now when x is 0, we've got that y, which equals x plus 1, because we're trying to sketch that curve. So y is 1, and when x is 0, e to the x is also 1. So it looks like we've got a point of intersection there. Okay. Now when x is 1, the y curve, y equals x plus 1 is 1 plus 1 is 2, and we'll have e to the 1 as well, which is just e, which is approximately, remember, 2.7. When x is 2, we've got that y is 3, and here we've got e squared. So I really need to just sketch, really x is 0 and 1, so I want the shaded area between those, but I might put the 2 or start to do the 2. Now, when x is 0, my straight line graph cuts through it 1, and e is about 2.7. I'm just going to put it up here. That would be e. So if this is 1, that's roughly 2, that's 3. E is about there, which is 2.7. Now, x-axis, y-axis. So the straight line graph, I know this scale here seems to be different from that, but that's okay. So when x is 1, when x is 0, for the straight line graph first, y is 1, when x is 1, y is 2. Obviously, when x is 2, y is 3. So this is my straight line graph. It is a little bit stretched on this x-axis, but it doesn't matter. Now, for my exponential curve, when x is 0, my e to the x curve is at e. When x is 1, when x is 0, I get 1 down here. So with the e to the x curve, when x is 0, y is 1, so it's the same point on the curve. That's an error there. When x is 1, I get e, which is up here. When x is 2, I get e squared, which is approximately 8 point something or something like that. This curve, I can put the -1 in here as well. When x is -1, we get 1 on e, which is a little fraction down here. So it actually looks like this, and it would continue to go up there. So remember, this is a straight line graph down here. This is my exponential curve, which goes like that. So if we want to shade the area between these two curves, it's in here. Okay? And the question is to shade the area between those curves and then find the area, write an integral for that area. We can see that the e to the x curve is above the y equals x plus 1 curve. So therefore the area, remember it's top curve minus bottom curve, it's the e to the x curve minus, we've got the straight line, minus the x plus 1 curve. So it'll be e to the x minus the x plus 1 dx. Remember, we're integrating between the values of 1 and 0. So if we integrate e to the x, we get e to the x. Actually, I might just write that out again. So it's the integral of e to the x minus 1. Just make sure you put the -1, not +1. Integrating e to the x, we get e to the x. Integrating x, we get x squared on 2. And integrating -1, we've got -x. And we substitute in our values of 1 and 0. So that gives us e to the 1 minus a half minus 1. Minus, substituting in 0, we get e to the 0 is 1 minus 0 here and 0 there. So it's e minus a half minus 1, which is, I'll just write it all out, minus a half minus 1 again. So it's minus 2.5, so it's e minus 5 on 2. That's the area, units squared. Okay. Now remember, e is about 2.7, so it's like 2.7 minus 2.5. So it's about 0.2, the area. Quite small. We can see that it is quite small. here is another question from exercise 13, exercise 13D. Okay. Applications of integration. Sketch the region bounded by the x-axis, the lines y equals x, and x equals 2, and the curve y equals e to the power of 1 minus x, and find its area. So, okay, just looking at a little table of values for y equals e to the 1 minus x. So, okay, when x is 0, we've got y is e to the 1. When x is 1, we get e to the 0, which is 1. When e is 2, we get e to the 1 minus 2. That's e to the negative 1, which is 1 on e. Okay? The reason I'm going up to x is 2 is that you're sketching the region bounded by the x-axis, the lines y equals x and x equals 2. What we're going to do first, let's just do this sketch e to the 1 minus x. So when x is 0, I'm just going to go again roughly 1, 2, 3, so e would be here. So when x is 0, y is e. When x is 1, I'm going to space out this axis a bit more. When x is 1, y is 1, so 1 would be here on the y-axis. When x is 2, we get 1 on e, which is, pretty small. It's about a third. So this curve looks like this. Now, notice I have stretched out my x-axis a bit compared to my y-axis. So when I sketch the line y equals x, that is when x is 1, y is 1. When x is 2, y is 2. Remember, this is about 2. Here's 3. When x is, say, 3, y is also 3. So here I've got the line y equals x. Of course, when x is 0, y is 0 as well. So you've got to be very careful here because you've been asked to sketch the region bounded by the x-axis, the the line y equals x, and the line x equals 2. So again, sketch the region bounded by the x-axis, the line y equals x, x equals 2, and the curve y equals, and there's the curve of y equals e to the 1 minus x. So by this, that line, this curve, and this line, looks like we're finding the area in here. Now, the area in there is not all underneath one curve. This area here on the left, this bit, is only underneath the straight line. I mean, you can integrate that, but that is just a right angle triangle. So the area, I'm just going to call this area 1, and here I've got area 2. Area 1 is just under this straight line, and this area actually is a right angle triangle with base 1 and height 1. So the area is a half, so this is area 1. It's a half times 1 times 1, which is 1/2 units squared. Area 2 here is the integral between 2 and 1. So this area here is area 2, integral between 2 and 1, and it lies underneath the curve e to the 1 minus x dx. So to integrate that, remember this is of the format e to the ax plus b is 1 over a, which is 1 over negative 1, e to the 1 minus x. Substituting in 2 and 1, and we get negative e. Now 1 minus 2 is negative 1 minus, actually what I might do, I just write that as negative e to the 1 minus x between the values of 2 and 1. Now I really don't want to be substituting, I want to pull this negative out, so it's negative e to the 1 minus x substituted between the values of 2 and 1. So I don't want to go negative, put something in, then go minus negative. So I've got negative, whatever this turns out to be. So e to the 1 minus 2 is e to the negative 1, minus e to the 1 minus 1 is e to the 0, which is 1. So I've got negative, this is 1 over e plus 1. So therefore, the total area is the sum of areas 1 and 2, which is a half minus 1 over e plus 1, which is 1 1/2, which is 3 over 2 minus 1 over e units squared. Now for question 11. The shape of a metal stud is created by rotating the curve y equals e to the x minus e to the negative x about the x-axis between x is 0 and x is a half. Find its volume. Firstly, writing the formula for volume. Know that volume is pi integral of between b and a of y squared dx. Just going to work out what y squared is over here. Now be very careful about this because you need to put this in brackets and expand accordingly. So this is like a minus b squared. And a minus b squared is a squared minus 2ab plus b squared. E to the x squared is e to the 2x. Remember, it's minus 2 times e to the x times e to the negative x. Because this is like a minus b squared is a squared minus 2 times a, I might just put a dot there, times a times b, plus e to the negative x squared. I'll just write it as e to the negative x squared, but it is e to the negative 2x. So that's e to the 2x minus 2. Now multiplying, bases are the same, add the indices. X plus negative x is e to the 0 plus e to the negative 2x. It's e to the 2x minus 2 plus e to the negative 2x. That's what we need to integrate. So just making sure you do that over the side and that you're integrating the correct thing. So that is just pi, a half and 0. And integrating e to the 2x plus e to the negative 2x. I'm just going to put that minus 2 on the end, minus 2. And that's now relatively straightforward. So you would get e to the, remember this is e to the ax plus b is 1/2 e to the 2x. Oops, I'll put e twice. So it's 1/2 e to the 2x plus 1 over negative 2 e to the negative 2x minus 2x. And we have the pi out the front and we're substituting in a half and 0. So therefore it's pi times a half. Now e to the 2 times a half is e to the 1, a half e, minus a half. Substituting a half we get e to the negative 1. Substituting a half here we get minus 1. Minus, substituting in 0 we get e to the 0, which is 1 over 2. Again here we get e to the 0, so it's minus a half. We substitute in 0 there, we get 0. So a half minus a half is 0, so we lose this whole second bracket, and we've just got pi. We've got a common denominator there of 2. Actually, I might take that out the front, so it's pi on 2. I've got e minus e to the negative 1. I'm just going to put this minus 1 here, because it's otherwise I've got to go minus 2 over 2. So looking at that, I need a bracket there, so just be careful. I probably won't pull this 2 out after all. I might just leave that back in there. So it's pi e minus e to the negative 1 over 2 minus 1. Just be careful because it's pi times all of that. So just make sure you're keeping that, you know, I'll pull this 1 away from that pi, which was wrong. So just be careful there. So it's that units cubed because it's volume.